Okay, we're going to continue on with reducing these radicals in exponential forms. Our first one is 6 to the cube root of 6 to the 2/3. So would you agree with me that 6 to the 2/3 is inside the cube root? So then cube root I can write as a power of 1/3. So that becomes 6 power to power I multiply to the 2/9, which becomes the 9th root of 6 squared. Which means the 9th root of 36, because I can still square the 6. Okay, let's try 3 to the square root 2, all raised to the 2 square root 2. So my base is 3, power to power I multiply, so square root 2 times 2 square root 2 is 3 to the 4th, which is 64. (27) to the 4th raised to the negative 1/12. So power to power I multiply, so that's 4 times negative 1/12, and that reduces to negative 1/3. So that is the cube root of 27 to the negative 1, which is 3 to the negative 1, which is 1/3. All right, so now on this one, inside I have cube root of 3. So I would write that as 3 to the 1/3. Outside I have 4th root. So 4th root is a power of 1/4. Power to power I multiply, so this is 3 to the 1/12, which means the 12th root of 3. Another way you can think of this is because I just multiplied these, I could multiply the 4 and the 3, and that would give me my 12th root. The next one is 16 to the 1.5. 1.5 is equivalent to the fraction 3/2. So 16 to the 3/2 means square root of 16 cubed. So the square root of 16 is 4, cubed is 64. Now the next one is not simplified because I can write in a smaller base. I can rewrite 4 as base 2. So the numerator is already base 2. So 2 to the square root 2, 4 would be 2 squared. Now my base is 2, and when I divide, I subtract. So I get square root 2 minus 2. Some people don't think of this one as being simplified, but can we still take that power of 2? 4 squared would be 16, and I still have the power square root 2. Now, when I add and subtract, the only way I can combine them is to have like radicals. For example, 3a plus 2a would be 5a, but 3a plus 2b cannot combine anymore. So just like you need the same variable, when you add and subtract radicals, you need the same radical. So this one simplifies to the square root of 9 times 10. Well, the square root of 9 is 3, so I have 3 square roots of 10. Then I have minus square root 10. So 3 square root 10 minus 1 square root 10 is 2 square root 10. I get a lot of students who will take the square root of 90 minus the square root of 10 is equivalent to the square root of 80. That definitely is wrong. It is not the same as 2 square roots of 10. So do not combine them when you add and subtract unless you have like radicals. So let's try this one. The cube root of 108. That would be the cube root of 9 times 12, which is the cube root of 3 times 3 and 3 times 4. Since there are 3 3's, it is 3 cube root 4. Now we have to simplify cube root of 32. So that is the cube root of 8 times 4. Well, the cube root of 8 is 2. So I have plus 2 cube root 4. 3 cube root 4 plus 2 cube root 4 is 5 cube root 4. Right? This time it's a negative 32 to the 2/5. So that would be the 5th root of a negative 32 squared. Well, the 5th root of a negative 32 is a negative 2. Remember, negatives always have to go in parentheses, and then I still have to square. So a negative 2 times a negative 2 is a positive 4. The cube root of 1/3. 1 does not divide 3, so I split it into 2. Cube root of 1 over cube root of 3, which is 1 over the cube root of 3. So I must rationalize the denominator. Multiply by 2 more cube root of 3's. So in the numerator, I have the cube root of 9 over 3. Cube root of 16 minus the cube root of 2. Let's see, this would be the cube root of 8 times 2. The cube root of 8 is 2, so this is 2 cube root 2 minus 1 cube root 2 would be 1 cube root 2. The 4th root of 81 would be 3. The 4th root of q to the 8th would be q to the 4. The 4th root of w to the negative 12 would be w to the negative 3. I can't have negative exponents, so it is 3q to the 4th over w cubed. It was an even root, so I must absolute value my odds. So the w cubed gets absolute valued. All right, on these we're going to put everything back into the root. So I'm looking for the 4th root of what gave me this answer. So I'm going to put my 4th root down. I presently had a 2x squared underneath the radical, so I'll keep that there. To put each of these back in, I am going to need 4 of them since my root was 4. So that means I need 4 2's, 4x cubed, and 4y to the 5ths. So that gives me 2 times 2 to the 4th. That's 2 times 16 is 32. X squared times x to the 12th. That gives me x to the 14th. And then I have y to the 20th. Okay, let's try the next one. I'm looking what all goes into the cube root. I presently had 3x squared y. Now I'm going to have to put 3 of each of these in there. So that means 4 cubed, x squared cubed, y to the 7th cubed. So now I do like terms. 3 times 64. 192. X squared times x to the 6th. That's x to the 8th. And then y to the 21st. Now you should be able to do all of your homework.